Now that we've given you a few examples as to how to mill and what the particular cutters are capable of, let's take a few minutes and go over the types of materials that you're likely to encounter. Remember, if we're going to be building a quality part, it needs to be made out of quality material as well as have precise tolerances. Let's go over some of the materials you're likely to experience: mild steels, alloyed steels, stainless steels, aluminums, tool steels, cast irons, brass and copper, plastics such as Delrin and nylon. In the mild steel category, for building parts, washers, bushings, different things of this nature, the 1000 series of material works really well. There's also some good leaded materials like 11L17 that machine really well. You get excellent cutter life, you've got high feed rates, you can really process a lot of parts in these materials. It's a non-critical material, it's not something that we would be heat treating. It's just spacer blocks, tooling fixtures, things of that nature can be made out of mild steels. Next, let's take a look at alloyed steels. These are usually our higher chromium-based steels, such as 4130, 4140, 41L42. The L designates some lead in the material, so it machines a lot better, and 4340. These are probably some of the most popular types of alloyed steels that you're going to be working with in the machine trades. They machine reasonably well. They heat treat up to 45, 48 Rockwell, depending upon the one that you choose, and are very popular for race car parts, parts that have a high stress application where we need a good high tensile strength and surface hardness. Many of you may be wondering, well, what type of cutters do I need to be using when machining these types of materials? For all of our mild steels, high-speed, cobalt, and carbide will work just fine. When we get into the alloy-based steels, 4130s, 4140s, 4340s, and just their normal annealed or normalized conditions, high-speed cobalt and carbide will work fine. If we have a heat-treated material such as 4140, 4340, where the Rockwell or the hardness of the material is above 38 to 40, carbide is usually the preferred tool under those applications. Otherwise, we're going to be wearing out the high-speed cutters and have them in the grind shop for touch-up. When we start machining stainless steels, 17-4, 416, and the 300 series stainlesses are by far the most popular. 17-4 is probably the best in terms of corrosion resistance. A lot of people whine and complain about machining 17-4. My experience has been if you use proper fluids and good sharp cutting tools that it machines just fine, especially in the annealed or normalized condition. 416 is usually a free machining type stainless. It's used a lot in the barrel industry. It has a reasonable amount of sulfur in it, so it does machine well. The 300 series of stainlesses, 303, 308, are also good materials. They will heat treat up hard. You want to watch on the 300 series. Keep the cutter moving across them. Use a good cutting fluid in that process. Anytime that we use a 17-4, which is a precipitation hardening stainless steel, anytime its Rockwell exceeds 40, again, carbide is probably the best choice. You can do it with cobalt, but you're going to get some squeaking noises. You're going to need to apply a lot of fluids anytime the Rockwell gets around 40 in that specific material. Next, let's take a look at aluminum. The majority of our tooling fixtures are going to be built out of aluminum. 2024 is an excellent tooling plate material. You'll have a hardness designation of T351 on it. Anytime in aluminum, we're going to be dealing with 4 specific numbers. That is the alloy of aluminum that we are using. The last number, T351, T6, T751, those are the hardnesses of those specific alloys. 6061 is an excellent material. It has a tendency to be a little gummy by comparison. I really prefer 7075 and a T6 hardness. It machines really well. It anodizes very well. That is my preferred material if I'm building toolings, jigs, and fixtures. Let's take a look at tool steels. If you're lucky enough to get a job in the mold making industry, you're going to be dealing with a lot of tool steels. D2, H13, S7, and A2. D2 is probably one of the toughest type materials that you're going to machine. You're going to use carbide cobalt cutters in most applications there. It's a very abrasion resistant material. S7 has good machining characteristics, very tough, durable material. If you're going to be building a part that's under a tremendous amount of stress or taking impacts, S7 is an excellent choice. Cast iron, we talked about that in our lathe series for those of you that watch that. Cast iron, we want to be really careful when we're clamping it on the table, not to put it under any stress where it's going to crack. We do not use any cutting fluids at all in cast iron. Carbide makes an excellent cutter choice when we're machining cast iron. Brass and copper, those are a couple you need to watch out for. They machine well. Copper, on the other hand, though, is a very sticky, grabby substance to machine, and you do not want to get too aggressive in the feed rate when we're machining copper. It has a tendency to want to suck the cutter into itself, especially under climb cutting conditions. So take your time, be careful with the copper. Don't use any fluids on the copper. On the brass, we can use a little bit of soluble oil. Seems to work pretty well. Plastics, we have Delrin and nylon. A lot of bushings, different hubs, things of that nature will be built out of a product called Delrin. More of a trade name. It's a nylon base type material. Machines really well. Again, we wouldn't be using any cutting fluids on the plastics or nylons at all. We want to use a 2-flute cutter, turn the RPMs up pretty high. Remember to put a radius in the corner a lot of times when we're machining with the nylons. Gives us a little bit extra strength. That pretty well concludes a lot of the materials that we're going to ask you to work with. If you desire more information on the specific types of materials, your local steel supply houses are capable of providing you with a book such as this one from the Earl M. Jorgensen Company. They're going to deal with the different steels, aluminums, and alloys that were quite popular in the machining industry. Let's take a look at the aluminum section and see what we find. Remember, we talked about 2024 aluminum. It's going to give us the color markings on the rod and a bar. The ends are usually painted red. This is one of the best known of the high-strength aluminum alloys. With its high strength and excellent fatigue resistance, it is used in advantage in structures and parts where a good strength-weight to ratio is desired. That's just part of the information that's available on 2024. Let's look at some additional information. We have specific applications, primarily used in the aircraft industry for structural components, tooling, truck wheels, etc. It also will tell us the machinability of this specific alloy in its different heat treatments. It'll also show the heat treatment of the material. Remember the T designations after the 4 numbers of the alloy, T3, 4, 361, etc. Look at the tremendous difference from the standard mill run or annealed condition with a tensile strength of 27,000 psi and a yield strength of 11. Now in a heat-treated condition of, let's say, T361, that same tensile strength goes to 72,000 psi and the yield to 57,000. So approximately 3 to 5 times the strength when we heat treat that alloy. You can see how valuable of a reference source these types of books can be. Now let's take a look in the machinery handbook at a different type of alloy. Like the Jorgensen catalog, the machinery handbook is an excellent source for information. One of the things I like best, we can look under specific steels and applications, and they make a recommendation as to the type of steel. Let's take a look at forgings that are heat treated. 6150 is the suggested material. If we're going to be doing gears that are carburized, 3120, 4125, 4320 are, again, excellent choices. Moving down to the bottom of the page, we can see gears, gear rings, gear transmissions, an excellent reference source if you have a specific application that we're trying to match. Simply consult the machinery handbook, look up the designated material, get on the hot phone, call up the local steel supply, and order a truckload for your next machining job. There is a wealth of information in the machinery handbook. Take the time to read it and become familiar with it. It will answer a tremendous amount of questions that you may have on alloys, machining operations, etc. Keep in mind that in different types of alloys, they're going to be color-coded on the end of the bar. Consult your local vendor from whom you are purchasing, and he'll be glad to give you the color code reference charts. Another thing I like to do is go to the local steel suppliers in the area. Usually they're going to have a rem pile that's filled with cut-off ends anywhere from 6 inches to 2 foot long. You can also buy aluminum plate and steel from these same vendors. It's a good idea to pick up a truckload of this next time you're in town because it's an invaluable source and it saves and makes you a lot of money in the long run. If a customer comes in and he needs you to machine a part 6-8 inches long, you're going to have to call up and buy a 20-foot bar from the local vendor. Again, this is money out of our pocket. If we want to use materials for a piece of tooling plate or a little jig and fixture, having our little bone pile in the corner can be an invaluable resource. Keep those things in mind the next time you're at your tool steel supply house.